Good afternoon, Wood Creek. Welcome back to DRA Academy. And today, we're going to have Mr. Riley Owls.
Yep. What's good, guys? All right, so today we're going to be talking about the Trp Operon. And so this is what a normal, this is happening in bacteria. It's called the E. coli bacteria. This can live in your body and it helps to regulate kind of your tryptophan and it helps produce it. All right, so E. coli bacterium. So say in your E. coli you have your DNA all up in here. There's no nucleus in bacteria, as you know, prokaryote. So it's just going to be a part of this DNA. Let's just say it's this segment here. All right, so this is going to be that segment of DNA. You're going to have your Trp E, Trp D, Trp C, Trp B, and Trp A. These are just parts of the DNA that code for the enzymes, which are in the process of making that tryptophan. And tryptophan is a amino acid, and so it's essential for many proteins. And then you got your promoter. Your promoter is where the RNA polymerase is going to bind. We talk about that during our protein synthesis. So normally your RNA polymerase would be, let's just say it's this blue guy. It'll bind here. And then it'll start reading all these trips and then send it off to the ribosome. Let's just say it's encompassing that. So this is your RNA polymerase. So this is the normal course of action. But this would only happen in a low tryptophan environment, because when you don't have much tryptophan, what are you going to want to do? You're going to want to make it so that you have it for your proteins. So, but when you're in a high tryptophan environment, you don't want to waste all of your resources making more tryptophan when you don't need it. So we have this thing called repressor, we have this thing called the Trp repressor. And what color? We'll just use this. Let's make it kind of like this. You have your Trp repressor here. Trp repressor. And when there is going to be tryptophan in your environment, such as this here, say there's a lot of tryptophan in your environment, it looks like this. This will bind to this Trp repressor, and then this Trp repressor is going to come here and block this RNA polymerase from binding and moving along that line to make all those enzymes, or make the RNA, the mRNA that codes for those enzymes, so that tryptophan isn't made anymore. So in a high tryptophan environment, you're going to have a lot of these, which are attaching to these Trp repressors. You're going to have a lot of tryptophan. I'll just make it TRP for now. You're going to have a lot of tryptophan, and this Trp repressor is going to be activated by this going into here. Let's show that. Tryptophan is going to go in there, and it's going to go to this operator area of the DNA, and it's going to block this RNA polymerase from basically moving down and making those mRNA to code for those enzymes. And now we'll show you the second way that it can do it as well.
Go.
All right, y'all ready for part 2? So this is going to be the enzyme reaction after the RNA or mRNA is made. These 3 enzymes, or probably more, but there's 3 enzymes just for the sake of our drawing. And so you're going to have this precursor 1 that this enzyme is going to make. This is all after protein synthesis. Precursor 1 going to make it into precursor 2, precursor 3, and then 3 is going to change that all the way into tryptophan. And the way tryptophan can basically inhibit this process is by coming up here and binding to the enzyme in order to stop this from reacting. So say it binds here, and then it's going to change the shape of this so that, let's just say instead of a circle, it's going to look like this now. Now it's going to look like that. So now how this thing can't bind in there anymore because now its shape has changed. So now it's never going to make it into precursor 2. as long as they're tryptophan. Now, say tryptophan is super low. There's not much tryptophan in the area. This tryptophan isn't going to be able to bind to this enzyme 1 because there's not going to be that much of it. This is going to be gone. And this is going to change back to normal. The normal little shape there. And now it's the circle again, and now we can create more tryptophan. And now we have too much tryptophan, so now this thing's going to come back up and inhibit it again. And this is called a negative feedback loop because the more tryptophan we have, the less the reaction is going to occur. Whereas if it were a positive feedback loop, the more tryptophan made, the more tryptophan is going to be made thereafter. But in this one, it's negative because less tryptophan is made, the higher density in your environment there is of tryptophan. So yeah.
I say subscribe.
What?
I say subscribe. Like
Oh yeah, subscribe and like to DRA Academy for more tips and tricks on your AP Bio final.
Merry Christmas!
Yeah!